All right, this is AP, AB, and BC Calculus. We are doing Unit 2, Section 6, which is derivative rules, constant sum, difference, and constant multiple. So let's go ahead and jump in. So the constant multiple rule, let f of x be a differentiable function and let k be a constant. If there is a number k in front of a differentiable function, then you can just differentiate the function and leave k in front. So here's what I mean by that. If you have a 5 in front of an x to the 6th, right? So 5 in front of an x to the 6th. X to the 6th we already know how to differentiate from our last video, which was the power rule. Sorry, we're beach balling. So we can just differentiate the x to the 6th, leaving the 5 in front, and we're going to get a 5 times that 6x to the 5th, or a 30x to the 5th. Okay? So let's go ahead and walk through an example 1. We're going to differentiate each function. So here, my f prime of x, I'm going to drop the 3 down in front to give me a negative 6, because the 3 times the negative 2, and I'm going to lower the power by 1 to get a negative 6x squared. Here, I'm going to rewrite before I differentiate, right? So I didn't do any calculus here, right? I've said that 5 root x is the same as 5x to the 1/2. So now my g prime of x, I'm going to drop that 1/2 down in front. 5 times 1/2 would be 5/2, x to the negative 1/2, and that answer is totally fine. If you wanted to rewrite it as this, you certainly could. I would suggest that this answer is fine unless you're asked to do something else with it. Here, again, I'm going to rewrite first and recognize that this is actually an 8 times an x to the negative 2nd. So now when I go to find my h prime of x, notice that I'm not saying that these things are equal because they're not, right? So these are not equal, right? G of x and g prime of x are different things. The same thing's true here, right? H of x and h prime of x are different things. So I'm going to get a negative 16, right? Because the 2 will multiply the 8, the negative 2 rather will multiply the 8. X to the negative 3rd, and that answer's fine, although I will say that a lot of people will choose to rewrite this answer this way because that's a pretty simple rewrite. All right, let's go ahead and try a P1. You can pause me if you want to do it without me. So I'm going to go ahead and do them. In this case, I need to rewrite the last two. The first one doesn't need to be rewritten. So my f prime of x is, I drop the 4 down in front to get a 40 x to the 3rd, right? Here I'm going to rewrite this as a negative 7x to the 1/4 before I differentiate. And then my g prime of x, again, notice that I make sure the notations are different, would be a negative 7/4 x to the negative 3/4. And you could clean that up if you want. I'm going to leave it that way. And then this one is a negative 5x to the negative 3rd. Again, notice that's not calculus. That's just some pre-calc skill, which means my h prime of x is going to be a positive 15x to the negative 4th. Or again, that's a 15 over an x to the 4th if you so choose. All right, moving forward. The sum and difference rules. So let f and g be differentiable functions. If we differentiate a sum or difference of them, we basically just differentiate the pieces. So for instance, if I asked you to differentiate the quantity x to the 4th plus x squared, I would just differentiate the x to the 4th, keep the plus sign, and differentiate the x squared. And that's it. So let's go ahead and walk through what that looks like. All right, so essentially, in order to differentiate, I'm going to do this right below because it's easier if I just do the individual pieces. Since this is a sum or difference, I just differentiate each piece. So when I differentiate the 5/2 x to the 4th, that's going to be a 20/2 x to the 3rd, which I'll clean up in a sec, minus a 6x to the 1st, which I'll clean up in a sec, plus a 0 because that is actually an 8x to the 0, right? So when I drop the 0 down in front, it knocks things out. So I'm going to get a 10x cubed minus 6x. Same thing here when I differentiate. Now, be mindful because this thing right here you need to rewrite before you start, right? So I would suggest you consider this an x to the 1/6 x to the 3rd. I think that's an easier way to look at this, but it's up to you. 2x minus 7. Okay, so now when I go to find my g prime of x, right, I'm going to differentiate each piece. So I'm going to get 3/6, which is going to be a half, but we'll clean that up in a sec, x to the 2nd, plus a 6x to the negative 3rd, plus a 2 minus a 0, right? So I end up getting 1/2 x squared plus, you're probably going to see this as a 6 over x cubed, but it doesn't really matter to me, plus a 2. You might also see this 1/2 x squared as an x squared over 2. Any of those are fine, right? And again, you could leave it as a 6x to the negative 3rd. That would be absolutely fine. Notice that it is an important piece of communication that I clarify whether I'm talking about g of x, which this entire top row right here is g of x, versus g prime of x. They're not the same thing. All right, so you go ahead and try the same thing on P2. Again, note that in B, you're probably going to want to rewrite some stuff before you start. So you try P2, pause me if you don't want me to do it. So when I do A, right, my f prime is going to be a negative 6/3, which I'm going to clean up in a sec, x to the 5th, plus a 32x to the 3rd minus a 6x squared plus a 5, technically x to the 0, right, if you need that step. I don't know if you do, plus a 0. So again, the 5x to the 0 is just a 5, right? So I'm going to get that this is a negative 2x to the 5th plus 32x cubed minus 6x squared plus a 5. And that's my f prime. Now, for b, right, when I go to differentiate g, I would suggest that you rewrite stuff first. You can ignore that that little line after the 8. It's just because when I screenshot it, there must have been the cursor in the window. So this is a 1/10 x to the 4th minus a 5x to the negative 3rd minus a 3x. If you need to call it 3x the first, you can. If it helps you to call this an 8x to the 0, you can. So when I differentiate, I'm going to get a 4/10, right? And if you want to leave it as 4/10, that's fine. If you want to make it a 0.4, that's fine. If you want to make it 2/5, that's fine. X to the 3rd plus a 15x to the negative 4th minus a 3 plus a 0, right? So I'm probably going to see this as 2/5 x cubed plus 15 over x to the 4th minus a 3. Sorry, I meant minus and I put a vertical line. It's probably going to look like that. All right. Moving forward. All right, so currently you don't know how to differentiate a product of functions, right? So you're going to learn the product rule, which is video 2.8, right? So that's 2 more units away for when you're given a product that you can't simplify, right? So if I give you a product right now, there has to be a way to distribute or FOIL or something so that it is no longer a product, okay? Oh, and actually, let's go back up for 1 second and just talk about an interesting thing here. So let's, before we proceed, let's just make a note about what happened when we differentiated constants, right? So as a random side note, right, what I want you to notice is that when we differentiate, if we differentiate with respect to x some constant, we always get 0. And the reason why is actually the power rule, right? Because that's a constant times an x to the 0. Right? So if you were to differentiate a constant times an x to the 0 would drop down. It would be cx the negative first, but because of that 0 that dropped down, everything's 0. Okay, so when you differentiate a constant, it just disappears. By the same note, it would be worth noting that when you differentiate a linear term, like this negative 3x, you just get negative 3. And that actually makes a lot of sense if you think about derivatives as slope, right? Because if you have a line negative 3x, the slope of that line is negative 3. So the derivative of negative 3x is just the number in front of the x. So side note, anyway, moving forward. If you're handed a product like this, f of x equals 3x squared times the quantity 2x plus 8, you temporarily do not know how to differentiate that the way it's written. So what you're going to have to do is you're going to have to distribute this and rewrite it as a 6x cubed plus a 24x squared. When you do that, now you can go ahead and differentiate using the power rule and the sum and difference rules and all that stuff that we've talked about. Okay, so let's go ahead and differentiate. Before we can differentiate this, I have to FOIL, right? So first would be a negative 6x cubed. Outer is going to be a plus 10x squared. Inner is going to be a plus 3x, and last is a minus 5, right? So this is still f of x. This is not f prime. So now my f prime of x, notice how I don't say they're equal at any point, would be a negative 18x to the second plus a 20x plus a 3. The 5 would differentiate away to 0, right? Just like we saw. Same thing for g, except I'm sure you're stoked when you see that there's a root, right? So that's a product, right? This is a multiplication, and I can't currently differentiate a product. I mean, I can, but you technically can't. So I'm going to have to distribute this first. So the first thing I'm going to suggest is that you rewrite this as an x to the 1/2, and then we're going to go ahead and distribute. So what's going to happen is I'm going to get an x to the 2 plus 1/2. Well, that's 4 halves plus 1/2, which is 5 halves, right? Plus a 3x to the, this is an x to the first, So that's x to the 2 halves plus a 1 half. That's an x to the 3 halves, right? Minus a 5x to the 1 half. So now I can differentiate, and my g prime of x is going to be 5 halves x to the 5 halves minus 1 is 5 halves minus 2 halves. So that's 3 halves, right? Plus, this is going to be a 9 halves. X to the 3 halves minus 1 is 3 halves minus 2 halves. So that's a 1 half, right? Minus 5 halves x to the 1 half minus 1 is a negative 1 half, right? And that's going to be my answer. And you could clean it up if you wanted, but that's good enough for me. All right, so let's go ahead and do a P3. Same idea, you're going to have to distribute before you can differentiate. So when I distribute this, I get a 5x cubed minus a 15x squared plus a 10x. Notice that's still f of x. F prime of x is going to be what happens when I apply the power rule to all three of these functions. So 15x squared minus 30x plus 10. And then down here, notice that this is actually an x to the 1/3, right? So I'm going to get that this is x to the 1/3 times, and if you want, you could actually rewrite these exponents in thirds already. Maybe that makes your life a little easier, right? 4x to the 3/3, you could call that a 3/3, plus a 6. If that's easier for you, that's fine. When you distribute, you're going to get an x to the 7/3 minus a 4x to the 4/3 plus a 6x to the 1/3. Okay, so now I still haven't differentiated. Down here, when I apply the power rule, I'm going to get 7/3 x to the, well, 7/3 minus 3/3, which would be 1, is 4/3, right? This will be a 16/3 x to the 4/3 minus 3/3 would be 1/3, right? And then this is going to be a 2 because it's 6/3, x to the negative 2/3, right? Because 1/3 minus 1 would be 1/3 minus 3/3. And that's going to be my answer. So that's a negative 2/3. I just did a terrible job of writing it. Okay. All right. And there are lots of ways that you could be asked to simplify this, but again, if you're not asked to use it again, there's not really a point in making yourself that miserable. So just like there's a product rule, there is a quotient rule. That's going to be our video 2.09, right? Unit 2, section 9. So if you're given a quotient right now, before you know the quotient rule, it must be possible to simplify it by distributing or splitting things into multiple fractions. So for example, f of x equals x squared plus 2x minus 3 all over an x. Well, that's a quotient, but you don't know how to do a quotient yet. So you're going to split it into 3 different fractions, right? X squared over x, 2x over x, and negative 3 over x, which simplifies to this. The other way you could do it, right, so if this wasn't your jam, the other way to picture it is you could picture this as an x to the negative first times these things, and you could distribute. And if you did that, you'd get x plus 2 minus 3x to the negative first, which is the same answer, okay? And then you can differentiate. All right, so let's go ahead and so notice when I differentiated, derivative of x was 1, derivative of the constant was 0, and the derivative of the negative 3 x to the negative first was a positive 3 x to the negative second. All right, so let's go ahead and walk through some examples. So in both of these, the first thing I have to do is simplify. So I'm going to go ahead and split this up into 3 fractions. Now, if you're able to do this in your head and you're thinking, Hogan, why would I have to write this out? That's totally fine. I'm going to generally show more work than you're required to, right? So this is going to be a 5x squared plus a 2 minus a 3x to the negative second. And again, if you didn't like that way of doing it, you could treat it like this and then distribute the x, right? That would get you to the same spot, I promise, if you did this. Okay, so, sorry, there you go. And if you, sorry, that wasn't an x, it was just a 3, my bad. Come on, eraser. Okay, so I promise if you did this and just distributed, come on, beach ball. There we go, that you get to the same answer. So either way, I'm here, okay? And now that means my f prime of x, when I differentiate the 5x squared, I get a 10x. When I differentiate the 2, I get a 0. And when I differentiate the negative 3x to the negative second, I get a plus 6x to the negative third. So chances are my answer is going to look like this. If we did the same thing for g, right? So for g, now this is one where I would suggest it's easier to distribute. So I would suggest that this is the easier option as opposed to making this into separate fractions. But again, it's up to you. Now you'll notice I'm already cheating and writing my exponents in thirds. Why am I doing that? Well, because I noticed that I'm going to have to combine with this exponent of a negative 1/3. So by writing x cubed as x to the 9/3 ahead of time, I'm just doing myself a solid and making my life slightly easier. You certainly don't have to do that. So I'm going to get an x to the 8/3, right, minus 8x to the 5/3 plus a 5x to the negative 1/3, and then I'm going to differentiate. So at that point, I still haven't done any calculus. This is why I say that it's frequently it's the algebra and the pre-calc that gets to you. So when I differentiate with the power rule, I'm going to get 8/3 x to the 8/3 minus 1 would be 8/3 minus 3/3. So that's a 5/3, right? Minus 40/3, because that's what happens when you do 5/3 times 8. X to the, well, that's going to be a 2/3, right? Because it's 5/3 minus 3/3, right? And then minus a 5/3 x to the, when I do negative 1/3 minus 3/3, I get a negative 4/3. And there we go. Right? And I would not suggest cleaning any of this up. Again, if you're not prompted to do so, why would you make your life harder? All right, so let's go ahead and do a P4. Same idea, and you can totally do it without me if you want. So my f of x, and again, notice I'm not differentiating yet, right? I'm going to either split this up into 2 fractions or into 3 fractions, or I'm going to think about it as multiplying by that x to the negative first and distributing. It really doesn't matter to me which one you pick. Either way, you get a negative 2x to the 4th plus a 10 plus a 4x to the negative first. That means that my f prime of x should be a negative 8x to the 3rd plus a 0, because the constant's going to derive to 0, and then a negative 4x to the negative 2nd. So you're probably going to see your answer as this. Again, the other answer is totally fine, and you shouldn't simplify if you don't have to. I certainly wouldn't simplify on these ugly root ones. For this one, I would suggest that you go ahead and distribute it as an x to the negative 1/2. It's harder to split it into fractions. Again, I'm going to do myself the solid of rewriting these exponents ahead of time as what I need the common denominator to be. So instead of leaving it as an x squared, I'm going to call it an x to the 4/2, which is the same thing, but is written in a way that's going to make my life easier. Just like instead of leaving this as a 3x, I'm going to call it a 3x to the 2/2, which is the same thing, but is going to make my life easier. When I distribute, I get that this is an x to the 3/2 plus a 3x to the 1/2 plus an x to the negative 1/2. That's a 1/2. It just kind of looks like a cube, my bad. So, so my g prime of x is going to be 3/2 x to the, well, 3/2 minus 1 is 1/2, right? Plus 3/2 x to the 1/2 minus 1 is a negative 1/2, right? And then minus 1/2 x to the negative 1/2 minus 1 is a negative 3/2. And that's my answer. Again, not a whole lot of reason that you would want to simplify this, because that's just not fun. All right, moving on. So now let's put some scales together. We're going to write the equation of a tangent line and a normal line to the curve at this value, right? Remember, anytime we talk about needing the equation of a line, I need 2 things. I need a point, which I already have half of, right? My point is 4 comma blank. I can find that point by plugging in 4. If I plug in f of 4, and again, this is not a calc scale, right? This is an algebra scale. I'm going to get 16 plus 20 plus 1 all over a 4. So I get 37/4. Not super fun, but it is what it is, and we'll survive. Okay, so I now have my point. The second thing I need is a slope, right? So I have my point. The second thing I need is a slope. I know that my slope for A is going to be f prime of 4. Right, that's my tangent slope. And I know that my slope for B is going to be the opposite reciprocal, right? That's my normal slope is going to be the opposite reciprocal. So I need to find the derivative of this function, which is going to use the scales that we just did in E4 and P4, right? So I'm going to rewrite f as, if I split this into 3 fractions, it's an x squared over an x plus a 5 over an x, 5x over x plus a 1 over an x. So that's the same as an x plus a 5 plus an x to the negative first, right? So when I differentiate, my f prime of x is going to be, the derivative of x is just a 1 plus a 0, and then this is going to be minus 1x to the negative second. So I seem to get a 1 minus a 1 over x squared. Now here it is worth, in my opinion, rewriting, because I have to use the derivative for something. When you have to use the derivative, you probably want to rewrite it in a nice way. So this seems to be a 1 minus a 1 over 16. Right? Which I think is 16/16 minus 1/16, or 15 over 16. So that's my tangent slope, right? So my tangent slope is a 15 over 16, which means my normal slope is a negative 16 over 15. So my answer to A is y minus the y value equals my slope, 15/16, times x minus 4. Or if you want to add over that 37/4, you could make this y equals 15 over 16 times the quantity x minus 4 plus a 37/4. And I want to point out it's really not worth cleaning this up in any way, right? And then my answer for B is exactly the answer I just wrote, except I'm going to change the 15 over 16 into a negative 16 over 15. Same exact answer. And that's it. Let me scroll down a smidge so you can see. All right, so we're going to do one last problem. You'll do a P5, and that'll be the end of this video. So go ahead and try P5, same thing, right? But again, you have to rewrite your f of x first. So notice, whenever I'm asked for an equation of a line, I need to know, when I see that I need two things. I need a point, which is -1 comma blank, and I need a slope. So I might as well go ahead and find the blank now, right? My f of -1 is going to be a 2 times a regular 1, and then this will be a -4. So I think I get a -8, right? So I now know my point. Great. That's the first thing I need. The second thing I need is a slope, right? I know that my tangent slope, mt, is going to be f prime of -1. And I know that my normal slope is going to be the opposite reciprocal, right? I'm going to find the tangent slope first, and then I'm going to flip slope, change sign. So I'm going to rewrite my f of x first as a 2x cubed minus a 6x squared, right? Because I can't differentiate a product yet with the stuff I know. And honestly, you wouldn't want to use a product rule on this anyway, even if you knew it. So this is a 6x squared minus a 12x, right? Which means my tangent slope is going to be f prime of -1, which seems to be a 6 plus a 12, or an 18. That means that my normal slope should be a -1 over 18. So then I have my two answers, right? And now, if you're already ahead of me with knowing how you could move the y over, that's certainly not cheating. So this is y minus the y value, which will be y minus a -8, equals my m, right, which is the 18, x minus the x value, which would be an x plus 1. So if I wanted to subtract that 8 over, I could get y equals 18 times the quantity x plus 1, all minus an 8. And if I wanted my answer for B, I'm going to do exactly the same thing, right? The only difference when I do the normal slope, sorry for the beach balling, still beach balling, okay. The only difference when I do the normal slope is I have to change that slope to the opposite reciprocal. So this is going to be a -1/18, x plus 1, still minus the 8, right? The only thing that changes between these two is the slope, all right? And that is our video for section 6 of Unit 2.